This movie picks up at slide 12 of chapter 9 and objective number 6. Differentiate between the following types of gauging: electronic, optical, and coordinate measuring machine, and also some of the other terms that are in number 7. Differentiate between the following terms. The first term we're going to talk about is a template. Okay, so gauging the profile of a workpiece is usually done with a template. So a template's like a thin metal piece of steel that's contoured with gauge tolerances to check certain features of a part. So that is a template. Commercial gauges. So commercial gauges are available. These are things you can buy right off the shelf somewhere to check, and they're usually like what we're talking about here is like inside radius gauges or outside radius gauges. You can buy these at McMaster-Carr, just regular inspection gauges. So that's what we're seeing, like an inside radius here, outside radius is being checked here. Then there's a screw pitch gauge. It gives you a visual indication of the pitch of a screw. Does the screw meet its pitch specification? Now here's a plug gauge. Now, typically a plug gauge can have a go side and a no-go side, and it's used to inspect a slot width or a hole diameter. There's going to be a separate presentation, a movie about a plug gauge and what go and no-go means if you haven't seen that before. Ring gauge. Now ring gauge is usually used in pairs, a go side and a no-go side. So they're used in pairs, and you can use that to inspect an outside diameter like a shaft or something like that. This is what a snap gauge is, and these are commercial gauges that you can buy, and then your gauge maker will set these tolerances. One will be for a go side, one will be a no-go side. And again, I'll have a movie that talks about what go and no-go means. Okay, and here's a slide that shows you how to use a ring gauge versus a snap gauge for a diameter. So a ring gauge will accept a part that's out of round, and a snap gauge can reject a part that's out of round. So take a good look at that slide. Here's another type of gauge. Here is a flush pin gauge. So essentially what you have here is a pin, or a plunger they call it, and it has a step that's machined into it. That step is equal to the total tolerance here. And then you put the part over top of the plug gauge, and the inspector can visually determine whether or not that part is within tolerance by visually comparing the surface of the part to the step in the plunger. That is called a flush pin gauge. Here's a tool that's used a lot in inspection of parts. It's called the dial indicator. That's used for checking flatness or parallelism. So really what they'll do is you'll have a granite plate here, and then you'll set your workpiece up on these gauge blocks, and then you have a height gauge over here with your dial indicator set up on it. And then what you'll do is take that height gauge and slide it over the granite block, and then the stylus, here's the stylus on the dial indicator, will measure the surface of the part, and what you're looking for is movement of the indicator. And they come in different sizes, and they come in different increments. Okay, there's like a 1/10 gauge is more precise than a 1,000th gauge. Next one I got for you is air gauges, and these are typically for inside diameters. What you'll see here is what you're doing is measuring the amount of flow that gets past the gauge head. Okay, so you have an indicator system right here, and then you have air flowing here. And then you'll have masters. These masters are built to very tight tolerances. You use the masters to calibrate the indicator here, and then when you put your part on, you can tell by the indication of the dial how far that part is compared to the master. That's called an air gauge. Then electronic gauges. Okay, electronic gauges use a stylus, and typically the stylus will contact the part. And then there's several kinds. There's a variable transformer, there's a strain gauge, and then there's a variable reluctance gauge. So here is the 3 types of strain gauge. Here's the stylus, and this is a variable transformer. So the position of the stylus inside the stylus is attached to the core, and the position of the stylus core inside the coil here gives you an output that's proportional to how far this stylus moves in this direction. Now here's a strain gauge type. You have a stylus that's connected to a cantilevered bar, and then there's these strain gauges over here, and any motion that's picked up by the stylus is measured by the deflection in the beam here, and then that goes back and is read by the electronics. And then here's a variable inductor. It's kind of similar to the variable transformer. You have a core and coils, and then you have leads coming from it, and then the electronics here pick up the position of the core. And we talk about those in these next 3 slides. Here's a good one, is a optical comparator. So really they call that a shadow graph. So it blows up the part on a big projection image. Then you can have a digital readout that you can measure how far it goes across. That's a very handy tool for measuring radiuses and contours and diameters, and it's just a very handy tool. Next one is a coordinate measuring machine. It's very flexible. It's a device that's capable of providing highly accurate dimensions and positional information. Usually it's built on a big computer base, and it's computer controlled, so you can program it. This is a cartoon of what one of them looks like. There's a bridge and a quill and a probe with a stylus, and it's all computer controlled. Okay, so that's the end of this movie. I'm going to talk about gauge allocation tolerances in the next movie. And that's the end of the chapter 9 slides.